So guys, we'll start with gravitation. That is the E part of the chapter. Okay, there's a 3E what we are doing now. So basically in this in the E part of this chapter, we are learning basically about universal law of gravitation. Okay, it is called as universal law of gravitation. Now first, what do you mean by universal law of gravitation? What does this law state? So this law states that between any two objects or between any two bodies, there is always a force of attraction. So say for example, out here I have a body whose mass is m1 and this is a body A. There is another body B whose mass is m2. Okay, now so according to the law of gravitation between any two bodies, like for example these two bodies A and B, there is a force of attraction, and the force of attraction between these two bodies is directly proportional to the product of their masses, and it is inversely proportional to the square of distance of separation. Okay, so what is R? R is basically the distance from the center of the body A to the center of the body B. So that distance is called as what here? R, distance of separation. Now if you combine these two equations, we'll get that F is proportional to m1 m2 upon R squared. Correct? Now if I want to remove the proportional sign, then I need to insert a constant over here. So I'll insert another constant over here, which we write it as G, capital G m1 m2 upon R squared. Here this capital G is called as a constant of proportionality, which is a gravitational constant. Okay, so this capital G is called as gravitational constant. Now if F is equal to G m1 m2 upon R squared, so what will be G equal to? So G will be equal to F R squared upon what? M1 into M2. So you'll get G, that is gravitational constant. Clear? Now about the units of gravitational constant. What will be the units of gravitational constant? So what is the unit of force? Newton. R means distance, right? So there'll be what? Meter squared. And M1 M2 is what? Upon kg. So it means kg raised to minus 2. Okay, I hope you got how. I wrote Newton for F, meter for distance, but a square, so meter squared. Mass is in kg and the other mass is also in kg, so it will become kg raised to minus 2. Now also this constant, okay, the value of this gravitational constant is equal to 6.67 into 10 raised to minus 11 Newton meter squared per kg squared. So you don't have the derivation of this value, but you need to know this value. So they can ask you state the value of gravitational constant along with the units. Okay. Now, so I'll repeat once again. What can you say about the gravitational force or the gravitational force between the two bodies? It will be directly proportional to the product of their masses, inversely proportional to the square of distance between them, and it is always attractive, which we already learned in the A part of the chapter, that gravitational force is always attractive, it is never repulsive. Fine. Okay guys, now next thing, now next thing is about what is the importance of this law of gravitation. What is its importance? So with the help of this law of gravitation, we could understand about the forces, okay, or the motion between of the celestial bodies. Like for example, how Earth moves around the sun, how moon moves around the Earth, motion of the Earth around the sun, or the motion of the moon around the Earth, and the motion of a freely falling body. So these are the three important, this is the importance of the law of gravitation. So first one was Earth around the Sun. Second one we can say what? Motion of the Moon around the Earth. And the last one is the motion of a freely falling body. So as we know, whenever you release any body, how does it move? Towards the center of the Earth. Now see, they may ask you, say this is the, okay, say for example, this is the Earth, here is the center of the Earth. Now here we've got two bodies, a body A and a body B. So now between body A and B, there is going to be what? A force of attraction. So like for example, if you're holding a pen in one hand and a pencil in another hand, they both should attract each other, right? According to the law we've learned. Now you must be wondering, why are they not attracting each other if the law says so? The reason is because the object which you're holding in your hand is getting attracted to each and every particle around you, each and every body around you. Like for example, in this picture, okay, what we are talking about, A is getting attracted by B, but at the same time, A is also getting attracted by whom? By the Earth. A is also getting attracted by the Earth. Now, the question is, which force is greater? Force exerted by B on A is greater, or force exerted by Earth on A is greater? Obviously, the force exerted by Earth on A is greater as compared to the force exerted by B on A. Why? Simply because Earth has a very high amount of mass. And if you remember, more the mass, more will be the force of attraction. Remember, the force exerted by B on A is equal to the force exerted by A on B. In fact, the force exerted by Earth on A is also equal to the force exerted by A on the Earth. So they both are pulling each other with the equal forces, but in opposite direction. So the amount of force they are exerting on each other is the same, that is not different. Clear? So the forces are the same. Now the question is, if I drop an object from the point A, that object A, where will it move? Will it go towards the Earth, or will the Earth go towards A? We all know that A will go towards the Earth. So why does Earth not move towards A? Because Earth has got high mass, so it has also got what? High inertia. So its inertia is too high, and that's why you cannot move it easily. So though they are exerting equal forces on each other, it's a body A which has to move towards the center of the Earth. Okay, so they can ask you, why does the Earth does not move towards the body A? Because Earth has got higher mass, so it also has got what? Higher amount of inertia. Okay, now next thing. So now we all also know what is the force due to gravity, right? The gravitational force, okay, which is acting on the objects or on the body, is basically called as what? Force due to gravity. That is, Earth will exert force on each and every body, and everything will be pulled towards the center of the Earth. So whenever you release any object, every object whenever released, you know how will it try to move? It will be pulled in such a way that it will be in the direction of the center of the Earth. Okay. Now, next thing is about, you need to know what is the difference between the mass and the weight. Okay, what is the difference between the mass and the weight? So as we know, what do you mean by weight? Weight is the gravitational pull which is acting on a body. That is called as the weight. The gravitational pull acting on a body. What is mass? It is the matter contained in a body. Second point, as we know, weight is a vector quantity, whereas mass is a scalar quantity. Number 3, weight is measured by a spring balance. I hope you know what a spring balance is. It is measured by a spring balance, whereas mass is measured by a beam balance, or it is also called as a physical balance. Okay, next thing, weight, since it's a vector quantity, means what? It will vary from place to place, whereas the mass will not vary. Weight is measured in the unit Newton, whereas mass is measured in the unit kg. So there are 5-6 points they have given. If you learn these 4 also is enough. Okay. Now next thing. Okay. This another thing which is also very important is about what's the relation between small g and capital G. So see, small g is what? Acceleration due to gravity. And what is capital G? The gravitational constant. Now, as we know, what is the force of gravity acting on any body? It will be what? M into A or M into G, mass into gravity. And according to Newton's law, what is the force exerted on any body? It will be equal to G into M upon R squared. What does capital M represent? So capital M is for the mass of the, let's say you can say mass of the earth or a planet. Okay, and the small r, or I like use capital R only because in the textbook they use capital R. There's a distance of separation between the two bodies. Now as we know that both of these forces are supposed to be equal, right? Like the force exerted by the earth on a body and the force exerted by the body on the earth, they both have to be what? Same. So I can say that therefore M into G is equal to Gmm upon R squared. So I can cancel M and M here. What will you get here now? Small g is equal to G into M upon R squared. Okay, so yeah, that's how you derive this formula. This question had come in the last year's paper, in the terminal paper. Now guys, one more last thing. We had learned already the derivations, we have learned about the equations of motion. So there were 3 equations of motion what you had learned about. The first one was V is equal to U plus AT. Second one was S is equal to UT plus half AT squared. And the third formula was V squared is equal to U squared plus 2AS. So now we are going to do the application of the same things only, same chapter. I mean the same formulas only, but we are going to apply in a different way. Now see, in the first case, let's say a body is falling freely. Now see, when a body is falling freely, what can you say about its initial velocity? It will be 0. Correct? When a body is falling freely, its initial will be 0. And its acceleration will be equal to what? Acceleration due to gravity. So this is only when a body is falling what? Freely downwards. Now what will your first formula become? V is equal to U plus AT. V is how much? V only. U is what? 0. A is equal to G and T is T. Clear? Now the next formula for B. S is equal to UT plus half AT squared. S is equal to UT plus half AT squared. So S will be S only. Again, what is U equal to? 0. Correct? U is 0. So what will this U into T become? 0. Plus half A is equal to G. So half GT squared. Is it clear, guys? See, in place of U I substitute 0. What is 0 into T? 0. Plus half into G into T squared. Then C, last part, is S is equal to V squared is equal to U squared plus 2AS. That's the third equation. But V is V only. U is 0. So 2GH. How we got H? So what we do is, because it's a vertical, instead of displacement, we write height. So if it is horizontal, we usually write S, distance or displacement. If it's vertical, we write as what? H. So the formula becomes 2GH. So now when they say body is falling freely, you can directly use this formula. Okay, I still prefer using the original formulas only, ABC, and then derive it instead of by hearting the new set of formulas. But you can also learn directly these formulas and do it if you are comfortable with this. Now this was a falling freely. Now the second type of the questions are when a body is thrown vertically upwards. So if you throw any object vertically upwards, what will happen? What will happen? What can you say about its final velocity? It will be 0. Your acceleration will be equal to minus g because you are throwing upwards, so it is negative. Very, very important. And your s will be equal to what? H only. Now let's start. What will be the first formula? V is equal to u plus at. So how much is V? We do not know. How much is u? Sorry, we know V. V is equal to what? 0. U is equal to what? U only. A is minus g and into t. So 0 equal to u minus gt. So u is equal to gt. First formula. Number 2. S is equal to ut plus half at squared, right? Now let's substitute again. What is S equal to? H ut plus half. What is A equal to? Minus g into t squared. So H is equal to ut minus half gt squared. Clear? So this is the formula for B. And the last formula C is v squared is equal to u squared plus 2as. Again substitute. V is V only. No, V is not V, sorry. V is equal to how much, guys? Check. What is V equal to? 0. See here, notice. V is equal to 0 is equal to u squared plus 2. A is equal to minus g. S is equal to what? H. 0 is equal to u squared minus 2gh. U squared is equal to 2gh. That's the formula. We can also say u is equal to square root of 2gh, or any ways you can learn it. Because out of all of these, the most important thing is to remember that whenever a body is thrown upwards, acceleration is negative. The most important thing to remember. That's why people usually make a mistake. Okay. And also remember that when a body is thrown vertically upwards, its final velocity is 0. Now, one last thing that you need to know. Remember that the gravity on the moon, gravity on moon is equal to 1/6 of the gravity on the earth. And so it will be 1/6 of 9.8, which is approximately 1.6 meter per second square. So we will be using these two concepts. Either gravity is 1/6 of earth or 1.6, depending upon the problem. Now because gravity is 1/6, what we can also say that weight of any body on moon will be equal to what? 1/6 of the weight of that body on earth. Okay, weight of any body on the moon is equal to 1/6 its weight on the earth. Clear? Also, where is the gravity maximum? So the gravity is maximum at the poles and the gravity is minimum at the equator. Also, if you are going away, also gravity is maximum on the surface of the earth. Go away from the earth's surface, gravity will decrease. If you go towards the center of the earth, gravity will decrease. And at the center of the earth, the gravity is what? 0. Okay. So that's all. Whatever we have discussed, write down everything, make your own notes. It's very, very important, all the formulas and all. Okay. So yeah, it's a very short explanation for E part.